The main idea in functional programming is functions as first-class citizens. And for me, based on my experience with functional programming, what I understand with this idea is it basically means that you can use functions the way you'd use variables. So if you imagine we have a variable int n, which is perhaps 10, we can have a function like public void count. Let's say this is a function that can count, and we can pass this n into this function. So it can be an argument to a function. So the thing with functional programming is instead of being limited to only passing variables, here, we can pass functions. So you can have a function do something, and this do something can receive operation 1, which is a function, and it can receive maybe operation 2, which is a function. And this operation 2 can be used inside, operation 1 and operation 2 can be used inside the function to perform operation 1 and to perform operation 2. So you can refer to those functions inside this function. So here we have functions as arguments, and those functions can be executed inline inside the inside do something. And some languages go as far as allowing you to declare functions within functions. So I can have a function here like void operation 3 that's declared inline inside this function, and I can give it something that it does. So it does x, and having declared it inline, you can even have it execute inside the scope of do something. So this is what we'll be looking at today. We'll try and create some first-class citizens, first-class citizen functions. We're going to give functions citizenship in the language so that they behave more like variables. So with that, let's check out an example here. So let's say we have a classic OOP example. If you have a car, the main operation that a car can do. So let me just recap. So in OOP, the way we would arrange the relationship between cars and other vehicles is we can have a class vehicle, and this class vehicle can be a superclass, and you can have a bus implement this vehicle. And when it implements the vehicle, it means that we are able to transfer functionality that was declared in the vehicle to the bus. You can have another type of vehicle like sedan, or which other type of vehicle, like a truck that implements as well. Since this is a class, so this bus can extend vehicle. So you can have another truck here that extends vehicle. So both of these will inherit the properties of vehicle. So we can do such a similar relationship with interfaces. So we can have an interface vehicle that has some abstract functions. And I know I'm preaching to the choir here because we've covered this. So you can have a void drive inside this vehicle interface. And when bus implements, when the bus implements the vehicle, it will override this drive function. So we'll be able to override the drive function. And also when track implements vehicle, it will end up overriding the function drive. So it will also override drive, which means it will add its own custom functionality to drive. Now, using a functional approach to this, we can consider a truck and a bus to have one characteristic, which is a characteristic, which is that they are all drivable. So you can drive a bus and you can drive a car. So instead of referring to their their top level behavior as, yes, yes.
Anything?
Oh, oh, whoa.
It's showing your desktop.
Oh, it's not showing the ID.
No.
Okay, I think I might have missed something here. Let me try and sharing again. Share screen. I hope that has not been for too long. Can you see my screen now?
Perfect.
Awesome. Thanks for that heads up. It happens. If it happens again, let me know so that I can fix it. But thanks for that. Yeah. So the main characteristic between the bus and the truck is that they are drivable. So we can rename our interface. Instead of calling it vehicle, we can name it drivable. So that will make this interface refer to anything that can be driven. And when drivable is implemented by any of these other classes, drivable. When drivable is implemented, there will be a requirement to override the function drive. So let's get this and see how we can use this. You can implement this this behavior. So let's write some real code. So you can declare an interface drivable. And this interface has the function drive abstract function. It's not implemented. And now we can have a class bus, and this bus implements drivable. It implements drivable. And because it implements drivable, we can override the drive function that's declared abstract. And this drive function will just handle driving. So you can say this is driving bus. And also with the truck, we can also implement drivable. And by implementing drivable, we can override it and we'll get drive there. So with this, you can say print line and we'll be able to get driving truck. So we have driving bus and driving truck. So the way we would use this is we can have an instance of drivable, and this is a truck, and we say it's equals to new truck. We can have drivable, and this is a bus, and you can say it's equals to new bus. So both of them are drivable. And when we call truck.drive, which is a function that's available, remember I'm referring to drivable now, and when we call bus.drive, we should be able to see what we get there. So we'll see when we call truck.drive, we get driving truck. Although it's drivable, its implementation is truck. When we call bus.drive, we get driving bus. So that's how that relationship can be passed down. So this is just a recap of inheritance, but it will be important what we cover next. So now that we have this, let's imagine we have a static function that is outside this inheritance hierarchy. And the static function, all it does is it registers, it does a global drive, for instance, let's say. So this is a global drive. And what it does a global drive. And it doesn't care which bus, or whether it's a bus, whether it's a car, whether it's a truck. All it does is it checks whether that thing is drivable, and it drives it. So you can imagine this is a very experienced driver. So they are not limited to a bus or a truck. As long as something is drivable, it will be able to drive it. So you can take that and drive. Okay. So now within our code, we can call this global driver and pass it a drivable, like a truck, and it will drive that. We can also call that global driver and pass it a bus, and it will drive the bus. So just like in the other case, we'll see that when we call global drive the truck, will drive the bus. Now, what we are seeing here is we are not passing data to global drive. We are passing behavior. We are passing this function drive. So in this case, we are passing drive that has driving bus. This other case, we are passing drive that has driving truck. So since we are talking about functional programming, and we just learned that in functional programming, you can actually pass functions as arguments. So instead of passing data, you can pass this function, this one, as an argument. So why don't we just pass the function instead of passing this drivable? So what we can do here is, since this receives a drivable, we can decide to pass the function. So you can copy this function, and so this is when we are driving truck, we can pass that here. Okay. And when we want to drive a bus, we can take this drive bus function and we can pass it here. So according to functional programming, this should work. And before Java 8, this was not possible in Java. You could not do this. But after Java 8, there was an introduction of something called Lambda expressions, or lambdas. And lambdas, what they allow you to do is essentially this passing functions the way you'd pass data. And this passing of functions is valid as long as I alter the syntax a little bit, remove the things that we don't need. So first of all, we don't need access modifiers because this will be limited to one scope. The other thing we don't need the return type. So since we're returning void, we don't need that return type. Also, we don't need to name the function because we're just using it in one place. It's not a variable. And then the other thing we need to add is this arrow function. So we can add an arrow function, and this just says this is the function arguments and this is the function body. And you can see now this is valid Java. So you can actually run this. So if we run it, in fact, since now we are functional, we no longer need these guys because we're able to pass the behavior. We moved from passing data to passing behavior. And if we run that, we can see that we have driving truck and driving bus, which is these two behaviors that we're able to pass. So this is how you can pass functions as arguments. And the only reason why we're able to pass that function as an argument is because our global driver receives a drivable. And what does a drivable do? It implements drive. So we can just pass that drive operation instead of passing a bus or a truck. So you can forget about objects. So in OOP, it's usually object-oriented programming. So you can remove the O from objects and just pass the operation when you're doing functional programming. And this can be made even better by simplifying it, removing those extra braces, and making this inline so that it's more concise. So this would be valid Java code. So if we run that, we'll see, we'll get a driving truck and driving bus, which is the operations that we were able to pass. Questions? Questions or comments? Those who are familiar with functional programming, if I missed anything. Okay, I think the thumbs up means it's clear. Okay, awesome. Let me see if there is any question in the chat. Okay, wonderful, wonderful. So now, since we are doing this, it means we don't even need these class declarations. We are no longer doing data-oriented. We are no longer doing object-oriented programming. So we can get rid of that. So we don't need that. So we end up with very concise code. We have an interface drivable with a function drive, and any global driver can receive the drivable as a function. So think of this as a function and use that as an argument. So here is where things get interesting. Remember the concept of functions as first-class citizens. So functions as first-class citizens. So where we are treating functions as variables, we can actually convert this function into an actual variable. So the same way you have var int, this function can be var drive. So this is drive track. So it can be a variable. Of course, it need to be drivable. I can't use var everywhere. I wish we could. But this is a variable, and we can pass that the way we would pass int a and then pass it to a function. So we can pass this drivable into global drive. The same way, we can extract this drive bus. We can extract this drive bus operation here, just highlighting, and we can make it a variable, and we can pass it as an argument. So we can pass that drive bus operation. And if we run it, we're able to see that passing them as arguments doesn't create problems. So which means you can actually store this operation somewhere and pass it to multiple other functions. Since it's a variable, you can have it somewhere, and then the same way you can have somebody's age stored somewhere, and then you pass it to a function A, function B, function C, function D. The same thing with this drive operation. You can have it as a variable somewhere, global or local, and then you can pass it to multiple functions. So for instance, this drive track can still be passed to this other function. So that is how you pass around functions into other functions. But this global drive is just a static function. It's still a function, and we are passing a function to it. So what if your function receives an argument? So for instance, when somebody drives, you want to get their license. So string license. So we can update our drivable interface and say, before you drive, give us your license. And now, whenever we are doing this drive operation, we must pass a driver's license here. And when global driver tries to drive anything, whether it's a truck, it's a bus, they have to give us a license. And maybe this license has a number like that. And now when they drive, whenever they drive, we need to understand that there's a variable that's been passed, which is this string license. And this is how you, to capture that argument, you can just use, you can use any symbol here. So remember, this is a part of the function where the arguments are passed in. So you can just list the arguments there. I don't like that IntelliJ is adding other things here, but it's just telling us the data type. So this is not code that's required. You can just use a symbol. So like this can be E. It can also be explicit like license. I don't know why I use the list there. So it can be license, and here when we are driving, we can capture that license. You can say driving with license that, and say license number is that, and we can do the same way with license number, and we can pass the license number. And now when we run it, we'll see that that argument can, so the license numbers, you can see driving truck with the license number that, driving truck with license number that. So our global, since it's our global driver, whether they are driving the truck or the bus, they'll have the same license number. So we're able to pass that as an argument. So there's a lot of interesting things that you can do with lambdas. You can so let's handle the third case, because since they're functions, they should be able to do everything a function can do. So a function can receive arguments, but also a function can have a return type. So let's say when they drive, we want the distance they've driven, the mileage, in kilometers, for instance. So we can return that as an int, and whenever they drive, we want to know how far they drove. So what we can do is, in our driving lambdas, we can so in our driving lambdas, we can calculate the distance and return it. So you can have a return type here, which is the distance. So let's say the way I calculate the distance is using a random number. So random, I think this is new random dot next int. So I'm just using a random number because we don't have the algorithm for calculating the distance, at least for this example. And here we can also return. So imagine there is a very nice sophisticated algorithm for calculating the distance hidden somewhere there. And you can see that. So we're able to return the distance. So this is the distance they've driven. To make it a bit more clear, we can have a variable here, distance, and we return that variable, distance. The thing you need to remember is whenever your lambda, because this is what we are referring to as the lambda, so whenever the body of your lambda spans more than one line, you need to use these curly braces, and you need to use an explicit return argument, so that you explicitly tell it at which point you're doing the return. So you can inline this, or you can have multiple, you can have a variable and return that variable. So that's entirely up to you, depending on how you want to make that implementation. And now, since this gives us the distance, we can go ahead and try and use that distance. So let's see. So first of all, let's run it and see. So you can see we have the license. After the lambda is executed, global driver. So when they drive, after they drive, we expect that after this drive, we get the distance the drive covered. So here I can say distance, and we can print the distance inside the global drive function. Distance covered, or distance is that distance in perhaps kilometers. And if we run it, we should see we have the distance here in kilometers. I didn't do bounds, so it's just a random number being printed. So essentially, you can pass arguments, you can return values from the lambda, and you can pass the lambda into other functions.